All right. So in this video, I'm going to show you how to use GPT and Claude to code as a non-technical business owner. So over the past 2 years, I've used GPT since 3.5 came out and Claude to create automations, no code, and even fully coded apps now, completely without the ability to code. I've created the best system, bar none, that will allow you to basically solve any single technical problem that you will ever face. So in this video, what I'm going to do is break down what that 4-step framework is. And I'm basically going to show you how to get around code-based problems without knowing how to code or even really being able to read it in the first place. So what I'm going to cover is the same stuff that I've used to build business infrastructure for multiple businesses, including my own and my previous lead generation agencies, coaching programs, and even SaaS companies. What I've used to help a bunch of agency owners build automations, project management systems, and a lot of the infrastructure that they would need in order to create a system, create a team, and then scale their team once they know that they can get good lead flow and good sales flow. And also how to build, host, and produce an internal app for a client that scrapes tens of thousands of Google Maps search pages per minute. Little project that's been going on in the background for a while, and a lot of the learnings are based on that whole process. So I'm going to be referencing that back and forth through this video. Don't take this as just being able to code. This is literally how to be able to make anything at all using AI, whether it be AI ad creatives or pictures, videos where, you know, it's like your face, but you just give it a script and it makes it look like you when it actually isn't you recording the thing. Other coded apps, newsletters, and a bunch of any particular code or text or image or video based stuff. All of it. The entire thing based on this process will allow you to do any of those things and allow you to get rid of certain niggly bits and certain bugs and certain things that you know are not what they're meant to be, but end up showing up anyways, and basically just how to fix that stuff. So that's basically what I'm going to cover. It's about how to solve any idea or problem that you don't know how to do, how to get AI to give you the exact answers every single time and make it work to specification, and how to fix errors without actually knowing what they kind of mean. So stick around to the end because I'm going to be giving you some free prompt templates that you can use to start coding even today. They're going to be basically on code, but you can take the ideas, and one of them is actually a meta prompt, which I'll go into detail about once I get into. But that specifically will allow you to make absolutely anything that you would want. So there's an 80-20 to this, and based on these 4 principles, you'll be able to build anything that you wish. So the first one is called black box thinking. Second is decomposition. Third is purposeful prompting. And fourth is the 7-fold path. So this entire thing is based on principles, and what I'm going to do as I go through this is basically just discuss them and break down what they mean, because they are the underpinning of every single method that I'm going to talk about moving forwards. And the first of that is creating better questions. So life punishes the vague wish and rewards the specific ask. I could have pulled out maybe 18 other quotes that will tell you the importance of having good questions as opposed to just searching randomly for different answers, because creating the question, putting in the work to make the good question is 90% of the work, especially when you have AI, which will just give you the answer anyways. The better you know your problems, the easier time you'll have creating a solution. And that's basically the underpinning of what this is, which is black box thinking. So number one is to think in terms of inputs and outputs. So the whole idea behind this is that you have an input, something happens to that input, and then you have an output afterwards. And the input is converted into an output using a number of processes that you may not particularly know, using the processes that you're going to create using AI, and that will spit out the output, which is what you need. So this type of thinking allows you to focus only on what matters. It's easy to describe a problem to anyone. It's easy to describe that problem to AI and to Claude, etc. If you know exactly what you're starting off with, you know what the end is, so you can work backwards from the end with what you have, which is 99% of the beauty of this idea. And you also know what the start is, so you know at a glance what series of transformations need to occur for you to get to the end. And for someone who, if for example you're creating a solution which is a coded application, your inputs are usually going to be some sort of whether it be, like a form or a button click or something along those lines, then there's going to be a series of processes, and then there's going to be an output, which is what you would need to work on. And even if you don't know what needs to happen with those outputs or with those transformations, because they are coded transformations, you can still get to where you need to go by literally asking the AI what the steps are, so that you know that part A, part B, part C, and part D needs to happen within this black box to get you the output that you would want. Begin with the end in mind and think of all of the attributes that your end solution needs to have. The final output will need to meet certain criteria, and once you can clearly solidify what that criteria is, your thought processes and your prompts will become clearer. So this is kind of like it's the beginning stage, but it gives you all of the context, or it gives you a nice way to think about the context upon which you're creating what you're creating. So say, for example, you're making, because this is something that will happen a lot of the times, when you use Zapier, Make, etc., NAN may be a little bit different, but there's still some level of cost associated with each individual run of the automation. Sometimes, in the example that I'm talking about, it might just be too cost effective for you to run the number of HTTP requests or automations for the thing to actually be profitable using no code solutions like Make and Zapier. So you may need to create some code that will do that for you. Usually it's going to be some level of some sort of Python code. And once you can clearly solidify what you're meant to come out with, you can tell the prompt to create the Python that will give you what you would need, and it will give you exactly what you need. And I'm going to go into that when we talk about step number 3. Step number 2 is to break your big, hairy problem into its constituent parts. This is what's called linear reduction, or what computer science people call decomposition. So the easiest way to describe this is by taking a big thing that needs to be done and breaking it down into the parts, and sometimes those parts have other parts in it. So let's say you want to make dinner. You want to make a 3-course meal. Let's say you have a date and they're coming to the house and you want to do something nice and fun and fantastic. Well, you know that a dinner, which is a 3-course meal, has a starter, a main course, and a dessert. So that's the first level of decomposition right there. The main course, let's say, for example, the starter is something that you can buy and you can just throw in the oven, and the dessert is also something that you can buy. You just put like ice cream on a cake and you can just leave it like that. So there's no extra things that need to be done. But for the main course, you would need to take the ingredients that you bought from the shop and then cook them and have them side by side. For example, a meat course and a vegetable course. For the meat, you would just make the chicken, make the beef, whatever it may be. And then for the vegetables, you would need to have your carb, whether it be protein, whether it be potatoes or rice, and then broccoli and some other stuff, whatever it is that you're trying to make. But you get the idea. You start off at the top, and the thing that is at the top can be broken down into its separate constituent parts. And some of those constituent parts may be too complex for you to just make because it doesn't insinuate a particular action, or there are multiple steps involved, which you need to then further break down so that you understand exactly what the intricate pieces are. This is what's called decomposing a problem. And when you can decompose a problem, you have a really good understanding of exactly where things need to be and exactly what you need to start off with. It's just breaking down the macro into the micro activities that need to happen. Just like with any problem, if you can break the things down into their constituent parts, you can take the necessary steps in order to create a solution. And you need to remember this when you want to start prompting, because the chances are you can't get your final output with one Claude prompt. So you have to think about chaining prompts across a whole conversation in order to get to a solution. Now, what this looks like usually is you'll have, if you're trying to make a coded app, or you're trying to make the back-end code or the server-side code that is going to do all the work in the background when little buttons are pressed and things like that are coming up. Though that thing that you want to happen, let's say in this situation, and I'll use a previous example, you want to scrape the entirety of Google Maps. Well, you know that to scrape the entirety of Google Maps insinuates a number of actions. Well, splitting them into their constituent parts, which is actually a technique called generic parts, you can ask yourself 2 questions. Can this be broken down further? And does the name of what I'm breaking down imply a use? I want to do multiple Google search scrapes. can be broken down into the multiple and the steps that need to be done in order for those multiple steps to occur. So if I'm trying to do, 10,000 HTTP requests in a minute, well, the steps involved in that are usually going to be creating something that will get you the raw materials, and then pushing those raw materials through a series of requests, and then having some sort of asynchronous function create the outputs and then push the output somewhere. Those are 4 separate parts. And oftentimes, if you were to ask Claude to do the top layer, then you'll mess up 1, mess up 2, get 3 a little bit right, and get 4 completely wrong. And then when you wanted to go back and test and debug and make sure things work, you'll be going in a loop and you'll be going round and round with Claude. So what you would need to do instead is break it down into its constituent parts. So just ask about step number 1. Get me all of the search parameters that I'm going to use before you make the actual post requests. So if you can tackle that alone, you can engineer a prompt that will give you all of that stuff, and you may only need to iterate on it once or twice in order to get that part to work. Then you move on to the next part, because you know that step 1 for this entire, macro action, step 1 is done, step 2 needs to be done next, and then step 3, and then step 4. That's kind of how you want to chain these conversations together as well. Number 3, create prompts where what you want and what you told it to give you are the same thing. The AI in and of itself is not dumb. We're now at a point where, and if you were to ask me this 3 years ago, when GPT 3.5 wasn't the thing and people were using LLMs on Hugging Face that had massive data sets but could only really do a few things here and there because the initial data set that the AI is powered from is just not big enough. If we were in that situation, then yes, you may tell it something which is exactly what you would want, and it would give you something else because it just wasn't good enough to do the entire thing. But now with 3.5 Sonnet, with 4.0, with 4.0 Mini, with O3 coming out as well, if you get the wrong output, it's your fault. If you entirely put the blame on yourself, you'll realize that you're probably giving AI the wrong anchor to attach to. So this is a nice step for us to look into what basically is the first principle of how AI works in and of itself when you feed it words. So vectors and vector databases are the knowledge bases that power large language models like 3.5 and 4.0 and so on and so forth. The basic understanding of this is that, you have like an X, a Y, and a Z axis, and you can just assume that each word has coordinates. A coordinate for the X, a coordinate for the Y, and a coordinate for the Z. The way that the words that are fed into the databases, the vector databases, which are, called embeddings, like the things that get fed into these databases, the way that they work is it's almost like a semantic brain, if you want to call it, where if a word has a similar semantic meaning to another word, they'll be close together. If it has a very different meaning to another word, it will be far apart. So you can see here, summary and breakdown are pretty close together. Summary and report are a little bit far apart. Report and story are completely separate. This is because when you feed the AI that word, it will take a meaning from that word and then it will compare that meaning with things that are around it. So closer equals more similar, and oftentimes, and there's like tests online that you can use to, show what this means, and those tests are called cosine similarity tests. So if I put Elon Musk and Melon Musk into one of these cosine similarity tests, they'll come out really, really close. If I was to put breakdown and summary together, they'd be a little bit further apart. Summary and report, a little bit further apart. Story and summary, quite far apart, because the meaning of those words is different. So you can see that the first principle behind all of this is simply comprehension. You have to be very, very explicit about the words you give it, because the meaning of one word versus the meaning of another word is literally 90% of the output quality. And the operative words tend to be, in my experience, the nouns, and also what you don't tell it to do. So if in this example, you are asking for a report, what AI knows about reports and what it knows about how reports are structured, formatted, etc., means that if what you didn't want was a report in a very structured manner that reports normally come in, because reports could be like financial, they could be governmental. These are just the semantic meanings that AI takes from the word report, and it will just give you one of those outputs which is similar to A, B, or C. If you didn't want that, you can't tell it report, because if you tell it report, it will give you something similar to those things. But if you wanted just a paragraph explaining the thing, then maybe a summary or a breakdown is a better word to use in that case. Those words are very, very important, because what happens is when you put the prompt in and you get your output, oftentimes you'll see what it spits out and you'll be like, wait, what are you doing? But then when you realize what you've actually written is what it's doing, then you say to yourself, okay, I know where it's gone wrong. It's taken the meaning of report. So it's taken this meaning as report. So let me just change that small part inside of the prompt. And the way that you can think about this in a nice structured way to kind of eliminate a lot of these problems is that the first prompt that you put in, which is usually called the system prompt, needs to have a number of things. And this is how you get AI to do exactly what you want it to do. So for the system prompts, there's usually, and this isn't, limited, this is just how prompt engineering up until this point has seen some of the best results. So we're always, working on experimenting. Everybody's always experimenting with different prompts to try and get different outputs. But most of all, you have these 6 things. You have a role, which is you are a blank. This gives it a nice contextual meaning and way of acting that the AI will basically take on. Then you have a core objective, which is usually your task is to blank, 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 blank in like one easy to read sentence. Then there's context, and context is literally exactly what you would think about when you're talking about context. Whatever your problem is, your problem sits contextually inside of something that that basically creates the guidelines and parameters for what you're looking for. Feeding it as much of that as humanly possible will get AI to be as accurate as humanly possible too. Formatting requirements is exactly how it looks. So if you want to format how the newsletter that you want it to write is coming out, then you need to be very specific about line breaks, indents, bullet points, numbered lists, and a bunch of other things, headings. And you can use things like HTML, so you can say H1, H2, H3, H4, just to create the hierarchy that you would want. Having all of that as an understanding, telling it, you need to speak eloquently, speak to a reading age of grade 6, a reading age of grade 5 to keep things simple. Imagine that you are talking to somebody who is 14 years old who does not know anything about blank subjects. Imagine you are talking to somebody who does not know code. These are the types of formatting requirements that you would use in order to get AI to give you exactly what you would want. Then you have examples, which is what shot prompting is. So few shot prompting, one shot prompting, that kind of stuff, just to give it a nice understanding of what it's meant to do. And one thing with examples is that if you are really good at AI prompting, sometimes you do not need a direct example. But what's good sometimes is if you're coding, for example, you have a data structure, i.e., I need an output that looks like this. And the output is, for example, let's say you've read some API documentation and you know that there's these sets of key value pairs, these sets of objects and arrays. You want to kind of like take that as an idea of what you want to give it as an example, so that everything that it creates within that structure. That's how I use examples for the most part, especially when things need to be really, really structured and really, really strict. But if I don't need that, sometimes I just don't use examples, and sometimes I can get away with not using examples. And then there's final messages, which usually come at the end, which are like the important considerations. For example, do not start off with X or Y or other preamble, just get straight into it. Sometimes you want to put that in there if the output that you want, which you usually find is, oh, here is the blank, blank, blank that you asked for, colon, and then it gives you it. If you want to avoid all of that, saying something like that usually gets rid of it. And those are things that you can just append to the end after iterating on the thing that you've gotten, or iterating on the system prompt, for example. With Claude, and I think GPT now has this, the best way to make this system prompt and project knowledge and, contextual information for what you need, for the problem that you need to solve, the best thing you can do is to put all of everything that I've just mentioned in the previous in a project alongside PDFs, documents, and other texts to provide AI with a knowledge base that it will use in order to solve the problem that you're asking it to solve. So number one, and when you're creating projects, this is what it will look like. Number one is just what the project is, and it's an explanation of the project. You know, I want to create a whole app from scratch, and this is the name of the title. And then number 2 is the project knowledge, which is just, it will just open up your files and you can just dump things in it. Now, I don't know about the online version right now because I've downloaded Claude on my desktop, but initially there was like a 5 or 6 PDF limit to project knowledge. But on the desktop version, I've put in pages upon pages upon pages, and I've only ever scratched the surface. I've only ever gone to like 10% of its capacity. So there is a lot of context that you could feed Claude when you download it on desktop to as context. And I'll show you about what context will look like later on inside of this video. Then you want to set your project instructions, and those project instructions are your master prompt, is your system prompt. So for example, when we're talking about project knowledge, we're talking about the documentation that you can feed it. You can feed it flowcharts. Let's say you have a process that you want to solve, and there is some level of, there's like a flow to it that you want to feed it as a PNG just into Claude. Claude can read images, so you actually it will see that this is the flowchart, and it will actually break down what the steps are because it can actually see it the same way that we can and derive meaning and comprehension from it. Requests and responses from API documentation is also a really good one if you're using code. For example, this is what goes in, this is what comes out, this is what goes in, this is what comes out for every step of the process that you may be doing. If there's multiple steps involved, then you're writing Python to do it. A synopsis of the problem, which is just the entirety of the context in paragraph format, such that the system prompt that you have, which is, not the full picture, is, that will be like 5 or 10% of it, but the other 90% of it will be inside of the project knowledge. It may include the background understanding that needs to be there in order for the context to be correct. So for example, because you can't always tell GPT or Claude, for example, we are doing work for blank, or this is the project and this is what it is, and have it understand that intuitively. Sometimes if you feed it that information and you feed it the background, you feed it the context in a lot of detail, it really gets the picture and it gives you only what you need. And then there's going to be other things like intricate details about anything you have to gloss over. So for example, calculations, any residing logic that needs to be put in, any glossary terms. Maybe you're using things inside of your prompts that you want it to refer to as blank or blank, and you want to make sure that it understands exactly what you mean, because the way that you are going to type into the chat is going to have certain words that you just want it to understand. That is an example of project knowledge. And if you feed the PDFs and the docs and the PNGs inside of the project before you start, it will have all of this and it will be ready to go. Now, sometimes you don't actually have all of the information you need to get the prompt right from the start. So sometimes you probably would just open up a separate chat, either in Claude on your on Chrome, or even a little 4.0 little ChatGPT chat over to the side that you can use to give you raw materials that you would need to make your prompt. And I'm going to give you the examples of some of the prompts that I use in order to create the prompt that I would put into the system prompt and just make my edits from there. And one big consideration is that your project knowledge should not really be made completely with AI, or at least it shouldn't be made solely with AI, because the problem is when you don't flesh out what AI gives to you, you start to rack up small errors over time to a point where once they compound and you start having conversations with the AI, you can run into errors that could be avoided if you just double check the project knowledge that you fed it. So that's prompting in and of itself. This step here is the most important step, because this is the step that will actually get you past the point of, oh, I know how to do this, to, oh no, I'm really, really stuck. I can't do this. This is how you get out of, I can't do this. When you run into errors, you need to progress in stages. And this actually uses everything that I've talked about already. And the principle behind this is called the sevenfold path. Now, if you read this, just gloss over it right now, what you'll realize is that this is the scientific method in a nutshell. Have a goal / problem, research it, form a hypothesis, or what I like to say is a plan, create the experiment, run the experiment, analyze your test, and then adjust and repeat from either step 2 or step 3. And this is probably the easiest way for me to explain exactly what that is, because if you follow this, you will solve every single problem you will ever run into. The scientific method alone will get you out of every single problem you will ever face. And what you need to do is you need to start off by isolating the issue and then formulate your plans. So if I just quickly go into this, I'm going to sort of like walk you through this, and I'm going to walk you through an example of me actually in the process of doing this for an app that I had made. So number one, do some research. Do some research is very, atypical or just broad in understanding. Sometimes there may be something tangential to what you need to solve, which you kind of realize you need to know in order to really be able to create a question that will solidify everything that you would need to know. The next step would be to isolate the problem, because sometimes, and again, this is the decomposition part, you have the big thing at the top. The big thing usually isn't the entire problem. The same way that the analogy that I like to use is that when you have a knot in a muscle, the muscle belly in and of itself feels really tight and really painful. But let's say the knot is like right in the middle of, your quad or something like that, or right in the middle of your calf, for example. Your gastroc, the little bulb right there in the middle of your calf, there's probably one really tiny point, which is where 99% of the pain is. If you just press your thumb into that, then you'll alleviate all of the pain across your entire calf. I like to think about these problems in the exact same way. If you can isolate a problem by decomposing what the goal or the problem is, and then finding the thing that you need to work on, you can put all of your energy towards that and then create a test that will work you all the way through until you get to a solution and you can move forward. So once you've done that, you would formulate your plans. And the way I like to look at this is, okay, I have a problem here, or this thing that I'm doing isn't working. I think if I do this, it will work. And sometimes there may be a couple of things that you think will work. So if I do this and I do this and I do this, or if I do this, I think it will work. If that doesn't work, I'm going to try this. If it doesn't work, I'm going to try this. Those are your plans. It's nice to have them written down on a notepad and then work through them. So like I have basically SOPs that I've, given my team, or that I've recorded that I need to give to my team, that entail or show me doing this live in action inside of make.com, because there'll be some times where you've run into a problem that you really don't know what's going on, but when you work through this process, you can actually find out what that problem is, and formulating the plans and then trying the plans step by step is how you work through the plans. Now, once you've formed the plan, you need to test the plan. So let's say you have plan A. If I use this module, if I use this variable instead of this variable inside of this module of my automation, I think it will work, and it will actually come back with a correct, the next step will just be correct when I test it. When you do this, the important thing is to only change one variable at a time. So let's say I'll give an example of one that I did months ago. I was trying to find the available times from a Calendly account, or from a Calendly event, and there were loads of problems with me trying to understand exactly how the automation was meant to work, because inside of this module there is the actual URL, and then there's the event that you want, including the URI or URL of that event, and then there's a start time and an end time. I would feed it and it would say this doesn't work. So the thing that I thought was the problem when having going back into the API documentation was the URI. I thought the URI was wrong. So I found another version of what I thought it would be, and I changed that. If I had changed that and changed the start date or the end date, I would have messed up the test, and I wouldn't have known for certain that the problem wasn't blank. It was blank. And this is what's called via negativa, which is a concept that Nassim Taleb talks about. But the whole understanding is that subtractive knowledge is more powerful than additional knowledge. Subtractive knowledge, knowing what doesn't work, is better than knowing what is better to as a fundamental idea when trying to solve problems than knowing what could work. Because if you know what doesn't work, you know that you can just not to do that and be closer to where you need to go. It's like if you're looking for, let's say you lost your wedding ring and you know that it's somewhere in the house. If you check your desktop table for it and it is nowhere to be found in every nook and cranny in that desktop, then you know that it's not here. Knowing that it's not here reduces the number of places that you could look for it. Because initially it was here, then it was here. Check the countertops, it's not there, and you know it's not there. All right, now we're going to check inside of the bed, underneath the bed, inside of the mattress, blah, 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 blah. Okay, it's not there. We'll check this part, we'll check this part, we'll check this part, we'll check this part. And then you narrow it down to it can only be in the kitchen, near the stove, or near the countertop. All right, it's on the countertop. We found it. That is the exact same process that you would follow in this situation. After you've created that plan and then you've tested it, You would find out if it worked or not. If it worked, amazing, great. If it didn't work, the best thing you can do is feed Claude the response. Just inside of the chat, next up, you could just say, this is what I got. It didn't work. This is what I got. And it can just be a snapshot of the thing, if it's because you can feed screenshots if needs be. Or it could be just the code that comes out of it, or the response that came out if you were creating copy, for example. If you fed Claude the response after it didn't work, then they would give you, usually, if you've prompted correctly, another iteration to try. It would say, okay, interesting. So what we'll do now then is we'll do this, this, and this, because if we can do this, this, and this, then we now know from a very informed perspective that this is what is the problem, not what you spoke about before. All right, so let's get into it then. Try it, let me know what happens. And then you would test that. And if it worked, great. If it didn't work, feed Claude the response. Sometimes you'll do this over and over again through, your own plans or what Claude tells you to do. And sometimes you may run out of plans. If you've run out of plans, this is where the emotional aspect of this whole thing comes to play. Sometimes you might just lose heart. If you don't lose heart, then great, things are still going well. Sit on it and continue forming more plans. All right, so plan A, plan B, plan C didn't work. I'm going to look into this a little bit more. Take 2-3 minutes looking at the problem in a couple of more ways, turn it upside down, have a little look somewhere else, and then, all right, I have another couple of plans. I'm going to try these, and then that will be what will take you through this process. And oftentimes, having a plan is enough motivation to give you enough hope to work through the next iteration and be one step closer to the solution, because it's more subtractive knowledge that you're accumulating. If you have lost heart, sometimes the problem that you're trying to tackle actually is bigger than how far you've decomposed. So you need to break down the problem even further and see if you can decompose what the initial problem is. If at that point, after doing a couple of tests, you can't break things down any further, take a walk, rest, sleep, just get out of the house, do something else, and have your mind percolate over the thing. Because what will end up happening is either you'll realize that you're looking at the problem in the wrong way, or you'll be able to just immediately form your plan, or you'll just have 4 or 5 extra plans come to you when you go into the shower and then come back again. This entire process is how you get out of every single problem you will ever face. And sometimes the step that you're on, that you're struggling to solve for, is a little bit more in-depth than it should be, so you can break it apart, like I just mentioned. Sometimes you need to roll back your code and start again from the point it was last working. So let's say if you were creating something, let's say you're creating a document, save as, and let's say you're writing a book, for example, who knows? And you had a massive Google document open, and at page 185 or page 190, you realize that the point that you are making is completely rubbish. You can just delete 2 or 3 pages of work and then get back to the point where you knew that things were smart, or that you knew things were okay. Maybe take some of those things that you deleted, put them away somewhere because you may need them later. Same thing with code. And this is something that softwares like Replit, I believe Cursor has this as well, where the AI is making the code for you. And sometimes you just get to a point where this isn't working. I don't know what's happening here, but I remember it was working at this stage, so I'm just going to go back. And it's called checkpoints. If you just go all the way back up to the last checkpoint, you can click that button and it will refresh the code up until that point, so that you can start from there knowing that that was what was working. When you prompt in this way, you can get any output that you want, because you can isolate every single part of the AI pipeline. You can isolate every single part of the problem, and once step 14 of 19, which is the hardest part of the problem, is solved, you can move on to step 15, and step 15 might be easy enough all the way through to 19, and now you have a solution, and bang, there you go. So that kind of breaks down all 4 of those steps. So I'm going to give you a bit of in the trench detail, just based on my own experience now with AI just in general. So Claude's on it 3.5 over GPT, even GPT 4.0. I don't know what it is, but Claude is just clean. It barely ever hallucinates, and I've never shouted at my screen at Claude. I've only ever done that at ChatGPT, because again, like we were saying, AI now is smart enough to where if you feed it something rubbish and it spits out rubbish, it's your fault. If you feed GPT beforehand, 3.5, even ChatGPT 4, if you fed it something that was, what was intended, or a chat goes on for a long time, there's almost like memory loss. And what happens is GPT just starts giving you stuff that you know is like out of format, or it's just not the right way that it's meant to be. So you have to either go back, or you have to reprompt it, or you literally just have to type out, no, this is wrong, you're being stupid, do better. And then it will just like fix up. You don't have to do that with Claude. So Claude over anything is the best thing that you can do. And you are limited with Claude 3.5 in the sense that I think it's like 40 or 50 chats. That is the limit for every, I would say, 4 hours. So you'll get to a point where it will say you are running out of texts or you are running out of messages. And then it will say Claude is disabled until 5 p.m. EST. And it's like 2 p.m. EST. At that point, you just got to go for a walk and then come back at 5 o'clock, because it will just move you down to Haiku instead of Sonnet. And Haiku is just not as good as Sonnet. So you do want to use Sonnet in that sense. 4.0 I reserve for very basic things that I want to ask AI outside of the main chat with Claude. So if I have a problem that can be solved, which doesn't really need any massive prompt in order for me to solve, like for example, I need to spin up an Airtable formula, or I need to find a meaning or find some understanding or some texts that I can look up and just ask it a simple question the same way that I would ask a Google search a question. 4.0 serves that purpose perfectly fine. And 4.0 mini is reserved for API calls where cost is a consideration and I'm doing something simple. So if I'm doing basic categorization, or I'm using Clayagent inside of Clay for cold email campaigns and things like that, I don't use Sonnet, I don't use 4.0, I don't use 0.1, I just use 4.0 mini, because you are probably going to be running a ton of API calls using 4.0. So you don't really need to be racking up the costs in that sense. Next, if you're using everything that I've spoken about so far to write code, you do have to pay attention to what's being spat out, because from time to time, a line will change at one point or another. And to combat this, you can add this to your system prompts. And this has been golden. As someone who can't code, as someone who doesn't know Python, but can just look at what's happening and, piece it together a little bit, perfect. Explain step by step what to copy and what to paste, one part at a time, including what the before and after should look like for the code. Tell me to replace this current code with this new code. And what ends up happening is, if you're in like Visual Studio Code or Replit, or you're just looking at something daunting, which is just all code based, and you've fed it an error and Claude is there basically saying, interesting, okay, maybe this didn't work, let's try this. Sometimes it will say, replace this function with this and do this instead of this. And you don't know what the hell it's talking about. But if you put this in here, it will say, replace this code with this code. And what you can see with that in and of itself is that you'll see what lines have changed, which means you can see if Claude is over hallucinating, which usually it doesn't. And you can also just go into Visual Studio Code or go into whatever it is that you're using, Control F, find where that thing is and just drag, copy, and then paste. And you also get the indentations right as well when you do it this way, because sometimes you can copy and paste based on what it's told you to do without this prompt, and it will give you stuff that actually isn't going to help you out. It's basically just, you've given me the wrong code, or you've given me poorly indented code because you've just forgotten what the code's meant to look like. Next, elaborate roles. Sometimes you need to just do things that will help you understand what's going on. And this is not only going to help you get to a solution, but it's also going to help teach you what's going on whilst it's happening. So sometimes you want to give it an elaborate role and then ask it to play teacher to help you consider things. So this one here is one that I've used. You're the top full stack CTO in the world. You know everything there is to know about DevOps, leading a team of developers, managing developer managers, scoping development projects, and all the technical know-how. I'm going to ask you questions that I want you to answer in excruciating detail. Leave no stone unturned. Think minimum 5 steps ahead, taking in any and every relevant contingency to solve the problem directly posed to you. Use everything you know from your custom development background in your answer. Then you want to feed it the context. You could say, my problem is this. I am doing this, this, and this is the problems that I am running into, blah, 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 blah. What I want you to do is to draw on your infinite experience as CTO to help me unlock my unconscious incompetence around scoping a project like this. My goal is to not get effed over by, in this case, it was scope creep, but I have no idea how not to. So you can replace scope creep with whatever the problem is, and you can just keep it going. We're going to go back and forth. Communicate with me like you're a teacher and ask me leading questions that I have to answer to better understand / uncover the missing information and contingencies. Ask one question at a time from most critical to scope creep to least. This will also break up what it's asking you, and then you just have a conversation back and forth, and it just gives you things back and forth, back and forth, back and forth. I've used this in and of itself to create the start of apps, because it would be, this is the problem that I am trying to solve. I know I need to use Python. I know I need to do this. I do not know code. I know that these are the steps that need to be done. Let's build this together. And then once that goes into the context part, the rest of it spits out and it says, all right, sweet. So based on what you're talking about, there's a really massive consideration that we need to take into account first. The first is these requirements. What are the rate limits of this software? And then it will just tell you to go and search up the thing and then give that information back. And it says, okay, interesting. So this is actually going to be considerably more blank than realized. So just wanted to make sure that you have A, B, and C in place. A, which is the question that will ask you next, and you answer it, then B, then C, and then it will go through all of those steps. And sometimes what I like to add to the end of this is, when you are at the end of when you know everything that you need to know, reply back with this sentence. And when you get to that point, it will say this sentence, and it would usually just be like a yes or no, like, are you ready for me to create the code, or are you ready for me to create the blank? And it will say yes, and then it will spit the thing out, and then you can use it and then put it off to the side. So that's a really good one, a really useful one. Then there's this meta prompt, which is a prompt that you can use to create the baseline of the system prompt that you're going to put into Claude. You're a prompt engineering expert who excels at creating precise structured outputs. Your task is to create a prompt that can be put into Claude. Details for what will go into the prompt to follow. Responses must be written at this, and this. So a lot of this is just about formatting. Use bold text for technical terms and italics for core concepts. Never use headings or titles. Instead, use clear paragraph breaks and white space to separate ideas. That was a personal decision, because I hate reading really broken up text that looks like AI. I'd rather you just give me sentences, because that actually doesn't look as much like AI, and it just goes in my brain a bit easier. So on and so forth. Use metaphors, analogies, explain complex ideas in simple terms. For example, if explaining data structures, compare them to real-world containers like boxes, shelves, or filing cabinets. I like to use like kitchens and recipes, because a lot of the times when like cooking things, the cooking things is synonymous with creating a lot of code. So sometimes when you feed it that, the code that spits out is like, say for example, you need to, because a lot of the code will start off with like import Flask, import this, import OS, import blank, and then the description for that is getting your kitchen utensils out onto the table. And then the next step would be defining certain functions, and those functions would be washing the vegetables or peeling the potatoes, and it will just say it like that, and it just goes into your brain a lot easier. And then the final thing is stirring the pot and serving up the food. That's kind of how I've used as an example of a metaphor to create certain pieces of code. So you'd spit all of that out, and then it will say, all right, great, what do you like? Tell me what needs to be known. And then you would put in all of the context that you have. If you haven't put it into a project, for example, you would want to just like drop a bunch of things, write a bunch of sentences, and then say, using the above and the specified guidelines, create the prompt. And that will give you a meta prompt, and it will spit it out, and then you can go and edit that yourself, and then use that inside of Claude when you are compiling all the documentation, and then that will be how you would start. And usually you can't go wrong with that. So to summarize, think in terms of inputs and outputs. The better you know your end goal and the context of your problem, the easier it will be for you to get the most out of the AI. Break your big, hairy problem into its constituent parts and use all of AI's power in solving each step one at a time. Decomposition is one of the biggest things here. Create prompts where what you want and what you told it to give you are the exact same thing. Pay very close attention to the words you give it, especially the nouns and directions you provide. Read back the output and make amendments accordingly. And then you want to iterate once or twice so that you can get it almost perfect. You don't really need to iterate too much. And more often than not, what good enough is perfect a lot of the times. When you run into errors, progress in stages. Iterate one at a time. Use the scientific method to solve your bugs. Remember the 7-fold path. Figure out what the problem is. Get your plans together. Once you've gotten your plans, test one plan at a time by testing one variable at a time. If that doesn't work, you know what doesn't work. Great. We now go to plan B. We know that doesn't work. We now go to plan C. We know that doesn't work. If we're, running out of ideas, we go back to the drawing board and make some. If we have a bit of if we're starting to get a little bit emotional about certain things, then we can just go for a walk and make sure that, we're in the right mind frame in order to get things sorted. And you want to manage your emotions by creating plans, rolling things back to previous versions, and taking breaks walks, or naps. So this in and of itself is everything that you would need to know in order to create code, create newsletters, create email templates, create whatever it is using AI. And in the next set of videos I'm going to make, I'm going to show some of these things and how these are being built out. But for something very, very related to this, click the link and I'll see you then.